look at its graph, it's going to look like an x squared or possibly a negative x squared. But whatever the case is, it's going to point in the same direction to the left and to the right. We can see the same thing if we look at the power of 4 as well as a power of 4 with a negative leading coefficient. Okay, so this is always going to be true. Again, just like the last one, if degree is even, again you have to look at the leading coefficient. The leading coefficient is positive, then the graph will open up to the left and up to the right. Whereas if the leading coefficient is negative, then the graph opens down to the left and down to the right. Okay, so that's always going to be true anytime you're dealing with graphs. Okay, so you should be able to identify that type of information. And the other thing that this allows you to do as we start adding now these higher degree polynomials is it allows if we're going to look to graph this, a couple things about this graph that you should be able to identify. First of all, what's the y-intercept? -3, right? Because the y-intercept is where x equals 0. So the y-intercept on any function is just the constant when you write it in standard form. So if we have 1, 2, 3, we know that our y-intercept is going to be down here. And now, again, we don't specifically know where the direction changes are going to take place, but what we can do here is we can make a prediction. What happens to the left of this graph? What should happen? And now we have an even power, so the end behavior is going to be the exact same. Is the leading coefficient positive or negative? Positive, so the left behavior and right behavior will both be ups, right? So again, it might change directions in here. Okay? It might come down like this. We don't know what happens in here. But what we do know is eventually the far left and the far right are going to point up. Okay. Now, any ideas on how you could find some more information about this graph before actually graphing it? Again, we're only going to go through this one time because you might be asked to do this in a future class. Okay. What other points can we actually find here? Can we find these points? Those are called what? X-intercepts. So you can find x-intercepts by doing what? Okay, now, careful on that. That winds up being just for the quadratic types. If you have a quadratic, you can't. But here, in the same idea is, what coordinates at these 2 points do we know? We know the x's are what we're looking for. We know that the y is going to be 0. So what we could do is we could solve this equation, x to the 4th minus 2x minus 3, and set it equal to 0. And when we solve for that x, we can find that here are your zeros, -1. So this is the point -1, 0. And then, and then this is the point 1.57, 0 approximately. So we can find our zeros on this. And then again, we know that the left behavior, or the left and right behavior, will both point up. again, all we know is it's going to intersect down here at -3. We don't know what's going to happen with the rest. And if we are asked to sketch this or graph it, easiest thing to do, you have your TI-89s. You can enter this function. Again, f of x is already replaced by the y1. And so you can just write your equation here. And when you look at the graph of this, it'll show you. And again, just a random guess. How close was the random guess? It's relatively close. Obviously, it's scaled off a little bit, but it even has the same kind of turns. Again, it's not always going to be that case, but you can predict what a graph should look like based on